Okay, so now that we've seen all these different effects, let's try to assess the normative model, the subjective expected utility theory. So, are people rational decision makers? Do people choose by calculating their subjective utility theory, which means do they choose by first getting a sense for the subjective value of a potential outcome and then getting a sense of the probability of it and then combining these two and picking the option that gives you the highest expected subjective utility? Well, I think we've seen enough data to support the idea that this is not really how the human mind works. It's a nice normative model of how we should or how an optimal choice might be carried out, but it doesn't seem to accurately capture how we actually do these things. If you think of it, the two core aspects of this theory just don't hold empirically. On the one hand, our preference set is not that nice, complete preference set that the theory requires it to be. Our perception of how valuable different options might be get pushed around by all sorts of irrelevant factors. Think of anchoring. You read the last two numbers of your social security number, and that affects the value that you are, the money that you're ready to spend on a certain item. Makes no sense, right? It's that shouldn't happen. Or because I frame something in positive or negative, I value differently the same option. Or if I already own something, suddenly it's valuable in a different way. Or if I built it versus you built it, the same object, I value differently the same object. Like clearly our preference set doesn't behave in that sort of nice way that it's supposed to for the normative models to work. Second, um, um, our ability to estimate the likeliness of an event to actually take place, which is the second cardinal aspect of the normative model, so that we can compute the expected utility or the expected subjective utility of something. Well, clearly, our ability to estimate the likeliness of events is far from accurate. Right? We've seen several different ways in which our perception of how probable an uncertain event is, is really in contrast to the actual known probabilities when you can calculate them. Think of the availability heuristic. We don't make the calculus of how probable something actually is. We just think, can I come up with many examples for it? And on the basis of that, we sort of impute how likely it is to happen. Same is true of the gambler's fallacy. We clearly don't have a good perception of how randomness works and how events, sort of what are the probabilities of events and what do independent events means and that sort of thing. The conjunction fallacy is another example. So it's really hard to argue that we choose by assessing the subjective by calculating the expected subjective utility, and by picking the option that gives us the maximal expected subjective utility, because we are not good at calculating value of something, or rather, our system for assigning value is very capricious in many ways. Second, we're not good at determining probabilities of events anyways. So clearly, we are not made for calculated expected utility. And if you think of it just more broadly, even if we were better than what we are at doing these two things, well-known cognitive limitations just make it hard for us to really employ, a real brute force approach in making these options. Think the classic example: you're choosing between, I don't know, 10 different cell phones that you might like to own. We don't have the cognitive capacity to go through every single option, rank every option, rank all the cell phones on all the options, assign, keep them all in mind at the same time, and by exactly weighting just how much each of the options we like, we multiply them all together and find what is the best cell phone. It's just, we really don't have the computational resources to keep in mind that many options and do all of this calculus. So if this is not what we're doing, what are we doing? Well, one interesting theory has been recently proposed by Daniel Kahneman. And it's often referred to either as system one, system two, or dual systems approach. But let me illustrate this with something that happened exactly 1 year ago, the day before I was preparing this exact lecture, which also means that I used it right away in my lecture. You might remember this. It was a fairly viral tweet during the run up to the election. So the following tweet happens and ends up on MSNBC, et cetera, et cetera. Bloomberg spent 500 millions on ads. The US population is 327 million people. Hence, Bloomberg could have given each American 1 million and still have money left over, to spare. Blah, 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 blah. Now, hopefully you're noticing that there's something very strange. But the tweeter clearly saying, well, look, 500 million, 327 million population, you could give 1 million each, and you'd still have, over 100 plus millions left, right, to take back. And of course, as you think this one through a little more carefully, you might go like, oh, no, sorry, I have to disagree, right? Not quite. Because if you have 500 million and if we are 327, then you can give each American $1.53. Right. So now this is the flavor. This is exactly the perfect illustration behind Danny Kahneman's idea. So Danny Kahneman posited that the way in which we reason and take decisions, rather, is the result of a balance and a dance and a synergy, rather, between two different ways of processing information inside the human brain. On the one hand, what he calls system one. This system is a fast, automatic, intuitive, typically non-conscious system, which is mostly based on pattern matching and heuristics. And this just tries to get an answer fast, based on whichever heuristic allows it to solve the problem. And then there's system two, which instead is kind of a slower, reflective, more deliberative type of, control the system, which instead, allows you to really think through a problem formally. So really crunch through the problem. So in terms of this tweet, system one would be the system that did a quick pattern matching and said, oh, 500 million, 327 million. Wow, I could give 1 million to each American and we'd all be rich. Right, so that's exactly system one. And system one does this very quickly, right? So quickly that she super quickly wrote this tweet. And typically system one and system two might be going on in the background. And system two is the voice that says, oh, wait, hold on a second. Let me think this one through. No, it's not that. If I have 500 million and we are 327 and I give each American can get $1, not 1 million. Right? So this is a wonderful example of how system one is responsible kind of for the quick heuristic. There's a lot of pattern matching going on, right? 500 million, 27 million. Well, I guess that gives, 1 million to each American. It's kind of a quick pattern matching type thing. And then, of course, the system two, which is slower, chimes in and says, okay, no, wait a second. Let's think this one through carefully. And then you go through the real calculation. System one doesn't do calculations. System one kind of does heuristics. System two, instead, does kind of the slow, more formal calculation. Now, in the lab, we often use this particular example to study these kind of things, which is known as the bat and ball problem. So consider this problem. A bat and a ball together costs $1.10. The bat costs $1 more than the ball. How much does the ball cost? Come on, quick. How much does the ball cost? Did you say 10 cents? That's the first answer that comes to mind. And just about 50% of participants say right away 10 cents. And this is your system one doing system one, giving you a rapid, automatic pattern matching. Look, we got a bat and a ball. The bat the bat costs $1 more. Here's $1, so I guess that will be the bat, will be $1, and the ball will probably be the $10, 10 cents. So again, system one is quickly pattern matching and using whatever heuristic it can to try to solve the problem. And you get to this answer. Then, of course, system two might kick in and say, wait a second, that doesn't work, right? As you think it sort of more slowly and more deliberately and sort of consciously, effortfully. At that point, you go like, no, wait a second, that it can't be, right? Because if the bat costs $1 more than the ball, then the ball must be 5 cents so that the bat can be $1.05. And now, right, everything fits. So this kind of reasoning, that would be your system two, kind of slowly and deliberatively, really crunching through the problem. And see, so system one then would be the system that is involved in many of the heuristics that we have seen, particularly in this last chapter. Think of belief bias. Belief bias is, instead of actually carrying out a deduction, system one says, look, if the conclusion is believable, then probably the deduction is valid. If the conclusion is unbelievable, probably the deduction is invalid. System one doesn't do logic. System one kind of uses these heuristics in order to solve a problem quickly, right? Of course, at the cost of being wrong. Same thing for the availability heuristic. System one doesn't calculate probabilities. However, if you ask me, well, how likely is a certain thing to happen? I can either sort of crunch through the numbers and try to calculate the probability of something, or I can just say, well, I don't know, let me think, how many examples of it can I come up with? If I can come up with a lot of examples, then it means that it's very likely. And so that's your system one at work. It uses the heuristic to try to solve the problem as quickly as it can. It doesn't do the formal calculation. It tries to find a shortcut to find a problem, and quickly to find the solution to a problem. To be clear, it's not that system one is bad. System one is a great way of reducing computational complexity and rapidly generating an answer without having to go through, kind of the intense, complex, and purposeful calculation for something. It's extremely adaptive. Of course, it risks being wrong. And so you have system one always kind of rapidly trying to generate answers, and then system two kind of can sort of take over. In a sense, when the going gets tough, right? Now system two can kind of take over, and try to sort of overwrite the answer of system one. Now, system two typically gets involved if there's more time. So one intuition, something might have happened to you, is that you have a problem, you give it a quick answer, right? Your system one kind of barks out the answer, and then just a couple seconds later, you go like, oh no, wait a second, let me think more carefully. So that's your system one having given a quick answer, and your system two overriding it and saying, let's think more carefully. Right? So sometimes if you just have more time, system two will do its thing, even if system one has kind of generated a quick answer. Now, similarly, there might just be some situations that just call for system two. Maybe it's an important decision. So you're not gonna give it a system one answer. You're gonna sit down and you're gonna go like, okay, let me think. So I really like this for this option, and I really like that for that option, and it's very likely to happen. And then for option two, I kind of really like this and that. Kind of there might be circumstances where you sit down and crunch through the problem slowly because the circumstance requires you to do that. Finally, there might even be situations where system one just doesn't generate an answer. And so all you have is system two. But think of doing, algebra, math, arithmetic, sorry. If I were to tell you, 2 + 2, you're going to bark out 4. And that's your system one at work. But if I were to tell you 27 times 13, system one goes silent. System one doesn't have a quick pattern matching for that. So system one doesn't have an answer, and system two says, all right, let's pull out a calculator or pen and paper, and kind of find our answer. So perhaps it is not that we take decisions by sort of using the Homo economicus model, the normative approach. Maybe that our mind is a collection of different processes, and these are not two different souls inside of you, kind of pulling you in different directions. They're just two different ways of processing information. A quick pattern matching way on one hand, and a kind of more slow, deliberative process on the other hand. So maybe it's through these kind of processes that we actually take decisions. Well, congratulations, you've reached the end of this course. I'm very sorry I didn't get to meet you in person, and I didn't get to discuss with you in person at office hours or before or after class. But I do hope that you've enjoyed this voyage in the human mind, and I do hope you got a good sense for what a fascinating topic and what a fascinating field the study of the human mind is. So good luck with your finals, and see you soon.